Hi everyone. So this is part 0 of FTC 9656 Omega's coding tutorial. Hopefully this will catch you up to speed on how the FTC code structure typically works, at least for our team. If you are a separate team, then this tutorial could be of use to you as well. We in Omega use standard structure, I'd say. So this is just a brief overview of what the code structure looks like and some objectives you want to keep in mind while coding. It's not going to be anything too technical. Okay, so it all starts off with a hardware class. You do not want to have, well, you could, but you do not want to place your hardware in every separate op mode. You want to have one initial base class for your hardware, which is where you're going to initialize all of your hardware. And you also have an init method, or in your op modes you're going to init the robot, and in that init method you're going to call and make an object out of this hardware class. So as you can see, I have teleop over here, and I have an init method that of course makes a new robot out of an Omega bot, and passes a telemetry and hardware map, which it inherits from op mode. So you can think of these two variables as just like, well, to be honest, I'm not really sure what they are, but they're just generic variables that you're supposed to pass into your hardware class. So moving on, so this is again a hardware class. You have your devices, your front left wheel, front right, etc., left flip, T marker, etc. You have your run mode declarations. So this is my run mode, and you can set this to whatever you want. This is just the default run mode. You can always change it later in an alt mode. Right now it's run to position. You can also calculate standard values, for example, ticks per inch. The reason why you want to calculate these values, and then store them in variables is because you do not want to repeatedly calculate these values later on. Say, like, if I want to make a move method and then I calculate whatever this equals to, let's say this equals like 7,900, or let's say 296.22, I don't want to type 296.22 times however many inches I want to travel. Every time I do want to travel, I can just type ticks per inch. So it's very useful to store these long values in variables. This is a double, and that means that it basically stores decimal numbers, whereas integers store, well, integers, counting numbers, 1, 2, 3, 4, 5, 6, or -1, -2, -3. So for Omega, we have ticks per inch, ticks per degree. Ticks per inch is, of course, for forward movements, or just, well, it can be rotational movements if you want it to be. Ticks per degree, which is more typical of rotational movement. There's a turn tolerance, how much we'll accept to be wrong by in degrees for turning. Drive tolerance, similar. Turn time limit, drive time limit per 1 foot. This is an orientation declaration, which is useful for our gyroscopic purposes. There's an IMU, inertial motion unit. It's our gyroscope plus accelerometer, and I believe there's something else that goes in, but basically it calculates, or for Omega purposes, it calculates your heading, what compass direction you're pointing towards, what angle you're at. We have declarations of Omega PID, basically instances of our PID class. Here is initialization of the hardware, and then finally we pass on default, or just we make generic methods that are very useful to other classes. For example, move time, move PID, turn using gyro, gets angle, turn using PID voltage, some getters, even though we probably don't need them if our variables are public, and yeah. So as an outline, OmegaBot is layer 0, and then as an optional layer 1, there is Autobase Rover Ruckus, which is a very basic autonomous class for the Rover Ruckus season. It basically follows or guides the robot up until it takes alternate paths depending on where the gold mineral is and whether it's facing the crater or the depot. So that's just initialization, and then it springs open its initialization, it's waiting for start, it opens its intake system to allow the camera to see the gold minerals, and then it scans, and then it selects the correct path. And then building on top of this optional layer 1, or actually for autonomous it's mandatory, at least according to our Omega structure, building on top of this layer comes real autonomous classes, so it extends Autobase Rover Ruckus. So it just runs that op mode, super.run op mode, and reminder that run op mode, the final line is it passes, that you can think of it as you're traveling in a forest and you suddenly turn center, turn right, or you go to the center, go to the right, go to the left. And then this class, of course, are the crater EXP. If you're in facing a crater, then you're going to implement left as so. This is what is defined as left if it's auto crater EXP. This is what's defined as go center. This is what's defined as go right. Same thing here, except this path is slightly different because you're not going to aim for the depot after the crater. Similar here, and that is an overview. Omega PID is a utility class. There are other utility classes that I may have forgotten to mention. Omega drivetrain can be thought of as a kind of like a small class that is contained within OmegaBot. This is very specific to the drivetrain and has some methods that are unique to it. Technically, this isn't actually necessary, but it is useful to have it separate just for organizational purposes. I think that about covers it.